Okay, what I want to do here is I want to just take a step back and look at some basic algebra from the what we've been doing here and just go back a step and just look at logically why this works. Why is it that we are working with adding, subtracting from one side of the equation, we must do it to the other side of the equation, and multiplication and division. So we basically have four functions. So I just want to make an expression here. So we're just going to work on this logic. Take a step back for a second, and we'll just think about this for a second, what we've been doing here. So I'm going to write an expression here. 2 plus 2 is equal to 6 minus 2. Okay, this is a true statement. 2 and 2 is 4. 6 minus 2 is 4. 4 is equal to 4. Okay, so now what I intend to do is do our four operations to this equation to demonstrate the logic of what we're doing. The first thing we're going to do is we're going to add. Now, it should be said, it doesn't matter if these were variables. For example, if 6 was represented by x, you would still need to do everything the same way. So numbers and variables, same idea. Okay, so we say that you need to add to both sides of the equations. So for example, right here, like if we wanted to get rid of this 2, we could add 2 to this side of the equation. We must add 2 to this side of the equation. I'm just going to go ahead and add 2. Now, I could just put 2. I'm adding 2 here to the front side. 2 plus 2 plus 2. So I added 2. A positive 2 is equal to 6 minus 2 plus 2. So I added this 2, and I added this 2, or you could even think of it as this 2, to this equation, right? So I added 2 to both sides of the equation, and essentially negative 2, recall that this minus 2 associated, this plus 2 would go to 0. But we don't need to do that now. We can just look at it. So 2 plus 2 plus 2 is 6. 6 minus 2 is 4, plus 2 is 6. Yep. So 6 is equal to 6. So what did we do? We added. We must do it to both sides of the equation. It makes the equation maintain its integrity. Okay? We can't just add 2 to this side and it would be a fallacy then. It's an algebraic process here. All right, so we did addition. I'll rewrite our equation here now. So we have 2 plus 2 plus 2 is equal to 6 minus 2 plus 2. So we've thrown in an addition. Now I'm going to subtract. So whatever I do to one side of the equation, I must do to the other side of the equation. Right? So I think I'll subtract 3. So I just write, I'm going to subtract 3 from both sides of the equation. Okay, so I'll now rewrite it as 2 plus 2 plus 2 minus 3 is equal to 6 minus 2 plus 2 minus 3. I could solve this equation. I mean, I could make it, reduce it, do the math here, but I want to demonstrate that by just doing these things to both sides of the equation, it doesn't matter where it would be in the equation. Here they both appear at the end. On this one, I actually put the 2 in the front and this other one at the back. It doesn't matter here. If you add 2 to the end or the beginning of this expression, it's going to be the same. Here I put them Just took away 3 at the end. So 2 plus 2 is 6 minus 3, 3. 6 minus 2, 4. Plus 2, 6 minus 3, 3. 3 is equal to 3. So it maintains its integrity again. All right, now we'll do some multiplication. So if I multiply, this is blue. So I'll go 2 plus 2 plus 2 minus 3 is equal to 6 minus 2 plus 2 minus 3. Okay, but I want to multiply this equation. I think I'll multiply it by 2. So it's 2 ways to think about this. Think about this as like you're going to be multiplying this entire piece times 2. Okay, that would be like distributive now. 2 times 2, 2 times 2, 2 times 2, 2 times negative 3, minus 6. Or you can see that sometimes I write it like this. I put the negative, or the 2 here, times each one of these. Right? Same idea. I just go about showing that I'm going to multiply each one by 2. Right? This is the same thing here. It's just going right through. So 2 times 2 is 4, plus 2 times 2 is 4, plus 2 times 2 is 4. 2 times a negative 3 is negative 6 is equal to 12. 6 times 2, negative 2 times 2, negative 4, plus 4 minus 6. Okay, so I've doubled everything. Just doubled it. Now, you could, in doing your rules of operation, you could just go 2 plus 2, 4, plus 2, 6, minus 3, 3, and do that inside, and then multiply by 2 and get 6, because that's going to be the same thing in the end, right? There's 4, 8, 12, minus 6, 6. You know, the rules of operation work as well, right? But just to demonstrate that we multiply this side and we multiply this side, I showed you 2 different ways. You'll often see me do it this way because we're going to be working with a variable. So it becomes a little easier. But you're very familiar with this distribution. You could write it like that. Okay, so it's maintained its integrity here. Now we'll go about dividing. So let's divide. All right, I think I'm going to rewrite it here. So here it is, 4 plus 4 plus 4 minus 6 is equal to 12 plus 4 minus 6. Okay, I think I'll divide it by 2. So now when I write like that, you have to understand that everything is divided by 2, not just the first 4, okay? This needs to be divided by 2. This needs to be divided by 2. This needs to be divided by 2. Or if you were to think about this in parentheses, you could add all these up and divide by 2. Okay, but you can't just divide the front 4 by 2 and think you're done. Everything is divided by 2. That's why sometimes you'll see me write it like this. I'm going to divide this side by 2. Okay? So everything on this side needs to be divided by 2. Okay? If we go about doing this, 4 and 4, 8, 12, minus 6, 6 divided by 2 would be equal to 3. 12 divided by 2 is 6. Minus 4 divided by 2 is 2, plus 4 divided by 2 is 2, minus 6 divided by 2 is 3. 6 minus 2 is 4, plus 2 is 6, minus 3 is 3. Three is equal to 3. All right? So, just logically thinking these things out. Here are your 4 operations, right? You're going to add. You need to add to both sides of the equations. And subtracting, it's really the same thing as adding, because you can add a negative. Think about it that way. And then multiplication. Showed you that you can use this distributive property. You'll see me write it like this because there's variables involved. Same thing. Different ways to look at it. And then when we divide, just make sure you don't just divide it once. This, if you do a division sign like this, put a 2 here, you have to understand that it's the entirety of that numerator. Okay, and we divided. So you can do these different tricks all you want. You can even zero out this side, right? Like if we were to subtract 3 from this side of the equation, we would need to subtract 3 from this side of the equation, and we would get 0 is equal to 0. Still true. So even if you working with variables and things and you zero one side of the equation, it's not a big deal as long as you're following the rules. Okay, so hopefully a simple logical explanation of what we are doing in these problems. For example, right here, we added 5 to this side of the equation, so we must add 5 to this side of the equation. Okay, in order to maintain the integrity of the equation. Just like we added 5 or added 2 here. No big deal when we did our addition. All right.